In this tutorial video, I will be solving a few trigonometric equations such as these. A lot of trigonometry relies on a certain amount of memorization, so I'm going to assume that you have memorized these facts. I'm going to also assume that you know some basic identities like, for example, sine squared theta plus cosine squared theta is equal to 1. That's the Pythagorean identity. This leads directly to the fact that tangent squared theta plus 1 is equal to secant squared theta, and cotangent squared theta plus 1 is equal to cosecant squared theta. So I'm going to assume you know these facts as well. Speaking of secant, cosecant, and cotangent, I'm going to also assume that you know that, let's see, cosecant is the reciprocal of sine, the sine function, and secant is the reciprocal of cosine. Okay, of course, cotangent is the reciprocal of tangent. Alright, I'm going to assume you know those things. Let's see, speaking of tangent and cotangent, I'm going to assume you know that tangent is sine over cosine. So therefore, cotangent is equal to cosine over sine. So all of this information needs to be bubbling around in your brain as you go to do these problems. Alright, enough background. Let us begin. We're going to find solutions between 0 and 2 pi. We'll include 0. We won't include 2 pi. All answers must be in exact terms of pi. So let's see how we can do problem number 1. Alright, this looks like a problem that might be factored. Compare this to, for example, instead of cosine squared, what if we just had 2x squared plus 3x plus 1 equals 0? We should be able to factor this probably, yeah? So 2x squared would be 2x times x. 1 would be 1 times 1. Inner plus outer must equal the middle. Inner, I have 1x. Outer, alright, if I multiply those, I have 2x. I'm trying to get a middle of 3x, so that would mean both of these need to stay positive, which would mean I have this. So I factored this, and I would go from there by setting each of these factors equal to 0. And I would solve from there. So we can do the same thing with trig functions. We can factor this, so watch carefully. It's going to be the same thing. So 2 cosine squared theta. I should be able to factor that as 2 cosine x times cosine x. If I multiply those together, I would get 2 cosine squared x. Now I look at the 1. 1 can only be 1 times 1, so that's easy. Still, inner plus outer must equal middle. Now inner, I have 1 cosine x. Outer, alright, if I multiply those, I have 2 cosine x. I'm trying to get a middle of 3 cosine x. So that means I need these just to stay positive. So that means this is positive and this is positive. Okay, so there we factored it. Now I'm going to set each of these equal to 0 and solve. So I have 2 cosine x plus 1 equals 0. And then over here I have cosine x plus 1 equals 0. Now over here I'm going to subtract 1 from both sides, so I have 2 cosine x is equal to negative 1. Dividing both sides by 2, I have cosine x is equal to negative 1/2. Alright, over here, if I subtract 1 from both sides, I have cosine x is equal to negative 1. Now, what angle will give me a cosine of 1/2? Alright, I'll worry about the negative later, but what angle, what reference angle gives me a cosine of 1/2? Remember this information that you should have memorized. Okay, so I've got cosine, here I've got 1/2, that's pi over 3. Cosine of pi over 3 is 1/2. Okay, so the reference angle has to be pi over 3. So the way I like to do this is I like to make a little circle. Alright, if I know my reference angle is pi over 3, now so far I have pi up here. So if I were to split this into 3 parts, okay, just focus on the top half of the semicircle. See how in the top now I have 3 parts? That means each of these is pi divided by 3. Okay, so that means at this position, alright, this is pi over 3, and the cosine would be 1/2 right here. Now, so basically at these 4 positions, cosine will either be 1/2 or negative 1/2, alright, but I'm going to get 1/2 all in every one of these 4 places. But I want the 2 places that are going to give me negative 1/2. So remember that cosine is like the x coordinate on the unit circle. So, you know, x values are negative over here to the left. Alright, you know what I mean? Like if this is my x-axis, this is the positive side, and this is the negative side. So that means these are the 2 places where I'm going to get a negative cosine, alright, because they're over here to on the left. So let's see. So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Okay, so those are my 2 solutions to this equation. Alright, I have 2 pi over 3 and 4 pi over 3 so far. Now what about negative 1? Again, I'm going to draw myself a little circle. Alright, a little unit circle. So where on the unit circle is cosine equal to negative 1? Again, this is going to be like an x value. So where is the x value going to be negative 1 on the unit circle? And that's going to be right here. Okay, alright, 1 unit to the left. This is going to be negative 1 comma 0. So the cosine is that x value. So here it is. So what angle is this? Well, this is pi, alright, because it's right at the semicircle. Let me clean this up. Okay, so what angle gives me negative 1? Pi gives me a cosine of negative 1. So I'm just going to add that to the list. So these are the 3 solutions to this equation. 2 pi over 3, 4 pi over 3, and pi. Alright, let's do one more in this video. Now here I have a combination of sine and cosine. That's never good. I want all one function, one trig function. So let's use the fact that sine squared x plus cosine squared x is equal to 1. Alright, that's something that we've memorized. If I get sine squared x by itself, Alright, I could do that by subtracting cosine squared from both sides. Running out of space over here. Oh no! Skirt! Like I said, I could subtract cosine squared x from both sides. So that would mean sine squared x is equal to 1 minus cosine squared x. So let's make that substitution. So now I have 2 cosine x plus 2 is equal to, but instead of sine squared x, I'm going to put 1 minus cosine squared x. Great. Now I have all cosines. Let's get 0 on one side. So let's subtract 1 from both sides, and let's add cosine squared x to both sides. Now there's no like term over here, so I'm just going to put my plus cosine squared x kind of in the front. So if I recopy this, I have cosine squared x, I'm just going to bring down, and then I'm going to bring that down this plus 2 cosine x, then 2 minus 1, so that's plus 1 is equal to 0. Alright, let's see if we can factor this like we did on the last problem. So cosine squared, that's cosine times cosine. 1 can only be 1 times 1. Now inner plus outer must equal the middle. Inner, I have 1 cosine x. Outer, I have 1 cosine x. I'm trying to get 2 cosine x, so I'll just leave the signs positive. Okay, so that means plus and plus. So there we have factored it. Normally we would set both of these equal to 0, but since they're the same, there's no point in doing it twice. So I'm just going to set one of these equal to 0, subtracting 1 from both sides, that's cosine is equal to negative 1. We just did this a minute ago, but let's look at the unit circle again. Alright, remember that cosine on the unit circle is simply the x coordinate. Alright, that's cosine. Okay, so where, considering that the radius is 1, obviously on my unit circle, radius of 1, where am I going to have a cosine of negative 1? Well, right here. Okay, this is going to be the point negative 1 comma 0. That's cosine. Cosine is the x value. And just like we saw this on the last problem, that's pi. So x is equal to pi. Alright, and that is the only solution. I think we have time for one more. Let's do problem number 3. Okay, again we have this combination of cosine and sine. So we don't want that. So again, let's use the fact that sine squared x is equal to 1 minus cosine squared x. And let's make that substitution. So let's see, I have cosine x plus 1 is equal to 2 times. Now, so I'm substituting 1 minus cosine squared x. So now I have cosine x plus 1 is equal to, we have to do some distributive properties, so that'll be 2 minus 2 cosine squared x. Let's get everything on one side. So let us subtract 2 from both sides, and let us add 2 cosine squared x to both sides. 2 cosine squared x. Alright, so let's combine like terms and bring everything down. There's no like term here, so I'm just going to bring down my 2 cosine squared x. And then I'm just going to bring down this cosine x. 1 minus 2 is negative 1, and all that equals 0. Now, probably we can factor this. 2 cosine squared, so that would be 2 cosine times cosine. Ignore the negative for now. 1 can only be 1 times 1. I like to do my signs last. Now, inner plus outer must equal the middle up here. Inner, I have 1 cosine x. Outer, I have 2 cosine x. Now, the middle right here is 1, positive 1 cosine x. So, how do I get a positive 1 out of this? Well, if I make this negative and this positive, that will give me positive 1. So that means this has to be negative to make the negative 1 cosine x inner, and this has to be positive to make the outer of positive 2 cosine x. And negative 1 times positive 1 makes negative 1. So everything works out great. So now we have factored it. So setting each of these equal to 0. So I have 2, I think I'm going to have to do this over here because I'm running out of space. Actually, it doesn't matter. Changed my mind. I can create more space. Just hit enter a few times. Okay, so like I said, let's set these equal to 0. So I have 2 cosine x minus 1 equals 0. And I have cosine x plus 1 equals 0. Over here I'm going to add that 1, so that'll give me 2 cosine x is equal to 1. Dividing by 2 on both sides gives me cosine x is equal to 1/2. Meanwhile, over here, subtract 1 from both sides, and I get cosine x is equal to negative 1. Okay, cosine equals 1/2. What angle has a cosine that equals 1/2? The cosine of what angle equals 1/2? This is one of those things that you should have memorized. Let's see, can I just drag this over a little bit? Skirt. Let's see, cosine 1/2, pi over 3. Cosine of pi over 3 is 1/2. So that's my reference angle for sure. Let's see, how do I want to do this? So since I have a reference angle of pi over 3, I'm going to draw pi over 3. So here's what pi over 3 looks like. Okay. Alright, the top half is pi, so that means each one of these slices is pi over 3. Okay, so these 4 positions, these 4 angles, will have a cosine of 1/2, except for 2 of them are positive and 2 of them are negative. So let's see, which are which? Well, remember, cosine is the x value on a unit circle. Okay, so remember how the x-axis works. Positive x is to the right and negative x's are to the left. So that means these 2 are negative and these 2 are positive, okay, for cosine. So we want the positive ones only because this is a positive 1/2. So that's going to be this angle and this angle. So this is pi over 3. Okay, 1 pi over 3. Now if I keep going around, this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So this is 5 pi over 3. So these are the x values that will give me positive 1/2. Alright, pi over 3 and 5 pi over 3. Now, what angle has a cosine equal to negative 1? I feel like we've done this many times. But again, since cosine is the x coordinate on the unit circle, this is the spot that has an x value of -1, because it's -1 to the left. And this is pi. Okay, so pi, the cosine of pi is equal to -1. So these are the answers to this problem. Alright, this video is long enough, so I'm going to stop it here. Alright, that was number 3.